A parallel capacitor A of capacitance C is charged by a battery to voltage V. The battery is disconnected and uncharged capacitor B of capacitance 2C is connected across A. Find the ratio of final charges on A and B, total electrostatic energy stored in A and B finally, and that stored in A initially. So, let us look into the situation. Initially, you have a capacitor C and you have charged by a battery. Let us say the total charge stored on this capacitance is Q. After this, we are removing the battery. So the capacitor is fully charged to a charge Q. Once it is fully charged, we are removing the battery and an uncharged capacitor of capacitance 2C is connected across it. So what will happen in this situation? The capacitor A is fully charged to a value of charge Q. Once you connect an uncharged capacitor, the charges will flow from the capacitor A to the capacitor B, because capacitor A is fully charged and capacitor B is empty. How long will the charges will flow? That we know. Once the potential becomes equal on both the capacitors, the charge flow will stop. And so we can say they will acquire a common potential V. So let us say V is the common potential for the capacitor A and capacitor B. So now once you connect the capacitor across, let us say now the charge on the first capacitor A as QA, and let us mark the charge on the second capacitor as QB. So we can say that the total charge Q will be equal to QA plus QB. That is, initial charge is Q that has been divided among the other two capacitors. So we can say the total charge is QA plus QB. Okay. Now we can write Q is equal to, the general expression for Q is C into V. So in this case, V is the common potential. So over here, in place of the first capacitor's charge QA, we can write it as capacitance of the first capacitor C and the potential is V. Similarly, for QB, we can write it as capacitance of the second capacitor is 2C into V. Now, let us substitute this value in the first equation. So, we can write Q is equal to QA. Q is nothing but CV and QB, that is nothing but 2CV. Once you substitute this, you will be getting TCV is equal to Q. So, from this we can write down V is equal to Q divided by 3C. So, we got the value of V as V is equal to Q by 3C. Now, we can calculate the final charges on A and B. What are the final charges on A and B? QA and QB. And QA is nothing but C into V. QB is nothing but 2 into CV. So, we can find out QA, which is equal to C into V. What is the common potential? We have found it out. That is Q divided by 3C. So, you'll be getting QA as Q by 3. And QB will be equal to 2C into V. V is nothing but Q by 3C. So, you'll be getting QB as 2Q by 3. So, these are the final charges on A and B. This is the first part question's answer. In the second part of the question, we need to find out the total electrostatic energy stored in A and B, and finally that was stored in A. So, we need to find the ratio of these two. So, what will be the energy stored in the beginning? The first part, only we have the capacitor C. The energy stored in the beginning will be half Q square by C, because Q is constant in the first, and the Q is 0 for the second capacitor. So, the energy stored in the second capacitor in the beginning will be 0. So, this is the energy stored in the capacitor in the beginning. Then, you need to find the electrostatic energy stored after we connect these two capacitors. So how much it will be? So you can write down energy stored will be equal to half into here in this case we can see the potential will remain constant, so we can write down half CV square. So half into C, the total capacitance is C plus 2C, that will be 3C into V square. How much is the value of V? That is Q by 3C. So Q by 3C whole square will come. Once you simplify this, you will be getting this as Q square by 3C. So now we can find the ratio of these two. The initial energy is half Q square by C and the final energy is Q square by 3Z. So once you take the ratio of EF by EI, you will be getting, let us substitute the values. That is Q square by 3C divided by EI is Q square by 2C. So here I forgot to write this half, so half is also there. So the half will get cancelled, so you will be getting the ratio as 1 by 3. This is the ratio of final energy to initial energy. This is the answer for the second